All right, so for today's lesson, we are going to approach triangles that are not 90 degrees. So I almost made a mistake, but you won't know that because I'm going to go through it normally. But I almost accidentally created a 90-degree triangle here. So I'm going to actually go straight to the example and say, hey, take a look at that triangle in example 1. Do you notice that it is not a 90 degree? I hope so. Why? Even if my drawing had a nice corner, if I do not give you a square, then you can't say it's a 90-degree triangle. And clearly, in this example, I do not have a 90-degree, I do not have a square in any of these corners. Okay? So what do? You cannot do SOHCAHTOA. If you want to put a little note next to that, just tell yourself, no SOHCAHTOA because no 90 degrees. You can't do SOHCAHTOA. I can't actually remember how many students insisted on always using SOHCAHTOA, even if there wasn't a 90 degree in previous years. But I know that there's a lot. So I need you to remember that you cannot use SOHCAHTOA here. So what do? Are we stuck? Are these triangles, out of our reach? No. Introducing the sine law. And we call it the sine law because notice, sine, 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 sine. The entire formula is made up of just the sine ratio. What is the ratio? Yes, you have a fraction involved, but you'll find it's pretty decent to maneuver, okay, decent to use. The sine law is a ratio of the angle and its opposite side. What do I mean by that? And you need to understand that every side and an angle are sort of matched with each other. Let me give you an example. If you want to draw this in the corner, please do so. I have with me a triangle. Okay. Let's call this triangle capital A as a corner, capital B as a corner, and capital C as a corner. Could you draw that with me very, very quickly? And I purposely made it so that it's not a 90-degree triangle, but even if it was, it is a mathematical convention that if a corner has an angle of capital A, then the furthest side from it is labeled as either length BC or it's labeled as the lowercase letter of the corner. Okay. So length BC can also be written as little a. Little b, capital B is up here. This is the corner. How about I use a different color? Okay. If this is angle B, the furthest side away is called little b. That takes me back. It's been a while since I did sine law. The last time I did sine law, no, it's a stupid stuff. Don't worry about it. Angle C is right here. And so the furthest side away is labeled little c. Okay. So this is what these letters represent. The sine, let's do this in blue. The sine of the angle in ratio with its opposite side, sine of angle B with its opposite side, sine of angle C with its opposite side. These ratios are always going to equal each other. Always. The same with this. And notice that if the ratios are the same here, I can flip these fractions as a reciprocal, and the reciprocal of each will still be the same. Here is my argument afterwards. Okay, so let me get the highlighter in blue. Sine A of over little a, sine B over little b, or sine C over little c, the fraction of the same. And this is my argument. It doesn't matter where the sine ratio is, top or bottom. But for example, if I say 1 over 2 is equal to 2 over 4, which is equal to 3 over 6, right? That is all the same because if you divide 1 over 2, that's 0.5. 2 divided by 4 is 0.5, and 3 divided by 6 is 0.5. On the flip side, 2 over 1 is equal to 4 over 2, which is equal to 6 over 3. Is that true? Yeah. Because 2 divided by 1 is a 2, 4 divided by 2 is a 2, and 6 divided by 3 is a 2. Yes, the numbers themselves, what the fraction equals can be different, but whether if I flip one of them, I have to flip all of them. As long as I'm consistent, I can use whichever formula that I want. Today's example, when I give it to you, you will see that I am going to flip them interchangeably whenever I feel like it's useful for me, right? So let's watch this. Let's see this in action. Looks like some people might still be copying, and so I would like everyone to take a look at this triangle. Sine law has a condition. It has to fulfill this condition if you want to use sine law. If you want to use sine law, the question, the triangle, has to give you information of 2 angles back to back plus one side, or an angle with another angle and a side in between it. So angle, side, angle, or 2 sides and then followed by a single angle. In other words, SSA. AAS, ASA, or SSA. If you don't like that, you can spell it reverse, but let's just leave it as SSA. Okay? As long as you have this, you can use sine law and it will work. If you do not, then you have to use something else, which I'll show you sometime in the future. But for the sake of your quiz coming up, I'll always give you a triangle where you can use sine law. But in the future, you have to be able to recognize it. Here we go. What do I mean by AAS, ASA, or SSA? Please, if you have a highlighter, go through or highlight the information that is given to you. I have a side, and without lifting a finger, what do I also have? Another side, and then without lifting your finger, what else do you have? An angle. So I have side, then a side, then an angle. Yes, it spells a not so nice word, but I'm not going to say anything. This is an acronym of SSA. I can use sine law. You understand what I mean by these acronyms? ASA, SSA, AAS. If you can find these 3 things without lifting your pen, then you can use sine law. And you'll see me do it again for the next example. Let's set it up. All right. What numbers are paired with each other? Please note that 41 degrees is paired with the 10.1 meters. They are pairs, right? Angle and its opposite side. So far, so good. This is important. So you have to recognize that it's they are matching. They are opposite sides. Next, angle B, which I don't know, is paired with 15.4 meters. And then angle C, which I don't know, is paired with little c. So let's set it up. Let's do it. Sine A over little a, sine B over little b, sine C over little c. This is sine of 41 degrees over 10.1. This fraction is equal to sine of capital B over little b. And that is the same as sine of big C, which I don't know, over little c, which I don't know. At this time, I invite you to look at what you wrote and see how it matches with the formula above. It matches with the above on the right. And so because you have to set up the formula right, it's super important that you match the correct angle inside. If you match the incorrect angle inside, well, no matter how good you are with your calculations, you won't get the right answer. So please recognize that we've got 15.4 with B, 10.1 with A, and angle C with side C, which I don't know. Okay. Let's do it. Where do we start first? Some of you might intuitively. The first one is here with, well, the A's are already solved. And then so we use this fraction to help solve. Which one do we start with? Because you can't do both at the same, it's too hard. Yes. Why do you think it makes sense to do the second one? There's only one unknown. So take a look at this, everyone. If I were to, don't write this down, sine 41 over 10.1 equals sine C over little c, there's way too many unknown numbers. You can't solve it. So by default, I am going to set up and start with, I'll do a different color here. I'm going to start with this. Here we go. Sine 41 divided by 10.1. Again, I can't do this without a calculator. Sine 41, oops, sine 41 divided by 10.1. Do you get 0.0649? Yeah. I'm running out of space, aren't I? Let me write it up here. And what's next? Let's get sine B all alone. Does this look familiar? How do we get rid of the denominator of a fraction? Yeah, I'm going to multiply both sides by 15.4. So 0.0649 times 15.4. Ooh.
Mr. Chumak, your presence is requested in room 204. Mr. Chumak, please go to room 204. Thank you.
Almost a 1. But it's really important. Angles are so sensitive. I need you to be as accurate as possible to 3 decimal places, okay? All right, and here's the last challenge. If you've been keeping up with homework, you may remember how to get the angle all alone and pull off sine from it. Got 2 people already answering something. Someone else will read today. Can I pick on someone? Oh, okay, go for it.
Is it you like your sign to the, did you get the 0.999 by multiplying
Correct.
it by?
Yeah, I'll write that down. Okay, so you want to pull the angle off of the ratio of the sine function. You are going to be doing the inverse of 0.999. And angle B, therefore, is going to be 87, I guess. Yeah, 87 437 degrees. Yeah. You will see my answer key is slightly different because I actually didn't round. I kept the decimals, which is, don't worry about it. Okay, but 87.437. Okay, that means this angle is taken care of. I'm just going to label it, say, hey, I got this. Okay, I got it. Let's find all the other ones. Okay, well, could I bring your attention back to what I paired with? I said before that I need one of these numbers to solve the other one. The fraction right now is there's too many unknowns. But this angle B will actually help you in the future calculation. Anyone know what the heck I'm talking about? Solving for angle B will actually help you with one of these. Alex? .41, which is A, and then I take away the angle B, which is 87.437, you get yourself what's left over. 87.41437, and that will be approximately 51.563 degrees. Okay, let's do it. I am going to take this now and pair it with this. I can do that now. So in blue, watch me. Sine of 41 degrees over 10.1 is now equal to angle C, 51.563 over little c. And you don't have to do what I'm going to do next, but I will wait until everyone's caught up because I want to show you something. Sort of a shortcut way to solve some issues. I will wait, no problem. Everyone's good? Yes? It's important. Everyone's good? Lesson. Do you notice that in the earlier calculation, my unknown was in the numerator? Do you notice now it's in the denominator? So it gets a little annoying. If you want to make it easy on yourself and you don't have to rely on things like cross multiplying or whatever, as I said, you can manipulate to the best of your ability. So Cameron, take a look. Are you ready? What do you notice between the previous line and what I have now? Yeah, so I can swap this as well. As long as I'm consistent, we're good. Once again, my argument, 1 over 2, if that's equal to 1 over 2, well, 2 over 1 is the same as 2 over 1, is it not? You get what I'm saying? As long as I'm consistent on both sides of the equal sign, things are okay. And so now let's solve it. 10.1 divided by sine 41 is approximately 15.395. And then c divided by sine of 15.563, sorry, 51.563 is 0.783 approximately. So sorry for writing it all over the place, but I'm running out of space. C is 15.395 multiplied by 0.73. This is 12.6 0.054 meters. Yes. Correct. To get C all alone. And that's it. Take a look. We began the question with 3 unknowns, right? So I'll write it in red. 3 unknowns. I didn't know this side. I didn't know this angle. I didn't know that angle. But using sine law, which is ratio equals ratio equals ratio, or fraction equals fraction equals fraction, I was able to solve all the unknowns, even if I didn't have a
Or C, the blank.
oh, we just found it.
Oh. In the angle.
Oh, right here. We were able to find it from the 180 thing.
Okay.
Yeah. So how about I label it? So this was this part right here. Here, let me do it by shading. This part, we calculated the first angle, and then using that, we calculated the second angle, and using that, we solve for the unknown. Welcome. Hayden arrived earlier. Micah just made it. Good. I know it might be fresh to some of you. Others might have seen it from last year. Either way, it's a single formula, and you can manipulate any way you want to make it more convenient. The next example is exactly the same, but as opposed to side angle, I have a different one for you. And that's it. Okay, the rest is yours to practice. And I don't see you on Thursday, which means on Friday, I will probably hound you a little bit more and make sure you can use both SOHCAHTOA and Sine Law for the upcoming quiz. Clear? Let's do this. Please turn the page. I will do it a little bit quicker and I'll get you started, hoping that you are able to finish it on your own time. Here we go. Using a highlighter, once again, you notice that this is not a 90-degree triangle. So you're going to check whether you can use side angle, angle side angle, or angle angle side. You'll get used to this acronym a little later as you practice more. Let's do it. Taking my highlighter, let's start with the left or rightmost. I'm just going to start with my leftmost. Here's an angle. And then without taking off my pen, I follow up with a side. And then right after, without taking off my pen, they give you another angle. So it's angle side angle. I can use Sine Law. Let's do it. I will write here. This is big N, that's little n. This is big M, this is little m. And that's big Q, that must be little q. Angle Q is paired with 114 kilometers. Angle M, 81, is paired with little m, which I don't know. And angle 55 is paired with little n, which I don't know. Before we begin, is there something we can do to draw more information out of this triangle? See, hand go straight up. I'll give you 30 seconds right away. Before you even do anything, if you see this, do it. What am I talking about?
There are 2 angles there, so
Right.
you can get all 3 angles.
Right. If you see this, do it first because solves so much and saves you so much headache. Okay, so once again, I know the total angles, the interior angles of a triangle is 180. So 180 minus 81 degrees minus 55 degrees is going to be angle Q, which is 44 degrees. So Q, I'm going to actually replace it right here. It's 44 degrees. Let's set it up. I'm going to, don't copy this. I am going to make an inconvenient mistake. Well, not mistake, but I'm going to create an inconvenience for you so that you can catch yourself instead. So I have such a habit of doing the sine first, always. I always write sine first, but for you, what do you notice about this setup? What is annoying? What is inconvenient? It's not really a trick question, huh? Well, this is true, but the way I set up the sine, you will find that it's annoying to calculate it. What do you think I'm talking about? People, someone else? Nicole, do you know what I'm talking about? Why is this? Why do you think I find this one more annoying than using the other formula? You can shrug your shoulders, no problem. Right, sure. So people that have been giving me answers already. Brandon, what about you? Are you with us? Okay. The question was, why is this formula a little bit more inconvenient than the other one? Why do you think? Nothing really to do with calculations per se. It's just when you're solving for other. Go ahead, Maria. So what I'm looking for is in the denominator. And when you do the algebra, you'll find that it's a little bit annoying. It's always nice if we don't have to worry about the variable at the denominator. And so, yeah, so let me show you what I mean. Sine 44 over 114 equals sine 81 over n. Is that okay? Okay, let's get n all alone. Go for it. Ooh. How do you get rid of a number on top? What do you multiply it with a number on the bottom so you can simplify it out? It's annoying, isn't it? No, it wouldn't be actually. Right? That's the annoying part. Remember, this is equal to sine 81 over 1 right here. How do you turn that into a 1? How do you essentially reduce it so that you don't have to worry? Well, you would have to have sine 81 in the denominator so that they will reduce into 1, right? It gets complicated, it gets annoying. So instead of doing all of that, when you set up the formula, have the numerator as the variable. So I'm going to do this instead. I am going to rewrite to make sure the numerator is the variable. So let's start. Solving 114 divided by sine 44. You should get 164.109. This is n over sine 81, which you should get 0.983. 8 rounded. I think, once again, you should be able to figure out what m is. Moving on, again, I'm not going to do that for you because I will trust you to try it. My next ratio will be that with this ratio. So I will set it up. 114 divided by sine 144 is 164.109. That is equal to n over sine 55, which is 0.819. Should be able to figure out there. And we found it. Sine law. Maria, question? How different? Did you do sine 44 first?
Yes.
And then maybe you rounded, what did you use? Did you use 0.7? 114 divided by 0.694, 164.2. It's close. I would be okay with that. Those are all rounding errors. And the higher you go in math, the more they'll say just learn to use the answer button and don't round it early. But right. So again, as you, for now, it's okay. But as you get into grade 12 or even university, they'll be like, don't round it all. Ooh. So be aware that that is a reality. For now, let's get used to the math, okay? That's it. So this is sine law. I don't see you until Friday, but I threw an entire formula at you. So I hope between now and Friday, you'll get a chance to try this formula in whatever shape or form is convenient to you, whether the variable's on the top or the bottom, whatever. The answer key for both number 2 as well as number 3 is going to be available to you online very soon. The challenge with number 3 is you have to draw your own acute triangle. So read that question carefully and see if you can solve it. Okay. And I believe this class is essentially over in 7 minutes. So try to finish number 2, get started on number 3, and the bell will signal your dismissal.